Well, good afternoon, everybody. My name is Carlos. I work in the Technological and Research Institute for Renewable Energies. And, well, I will explain more or less what is it. These are our installations. We had sun, wind, and the sea near, so it's a good place if you like windsurfing or kite surfing. We also have a building here. Is our data center. It has a power plant solar power plant in the roof, so it can during the day, and if it's not cloudy, it can self-consume the energy he's generating. And inside that data center, there is a supercomputer. It's a project where I work. There are many other projects. If you go for tourism, we have a path with many explanations of the renewable energies in the last 25 years that has the company. Well, ITER has many development areas with renewable, photovoltaics, architecture, wind energy. There are also some environment science. Tenerife has a volcano. It's the bigger mountain in Spain. So, and it's not active recently, but it already has smoke. And well, in the IT department is where we work. TeideHPC supercomputing was released in the top 500 in November 2013, and it was ranked 138, also in the Green 500, sorry. And well, we dedicate that infrastructure to many areas of weather forecasting, bioinformatics, computational fluid dynamics, astrophysics. We work closely with the Canarian Astrophysics Institute. It's a world-leading institution with many telescopes in La Palma and Tenerife. Computer science in areas maybe heuristic, meta-heuristics, streaming services for the city councils in the island, render and cloud computing. Our render experience is over the cloud platform where we use OpenNebula. First of all, I will talk how we implemented our solution. I will talk some study cases, well, not in much depth because Marco has a great experience and has explained it just before. One case with interoperability and some use cases that I wanted to tell you some things, not all the good things on the OpenNebula, because I think you all know OpenNebula is a good tool. I wanted to look for some tricks, but it was really difficult. So I start with the implementation. We self-made an API because the main purpose of the supercomputing of the supercomputer is the high performance computing, is scientific executions, and we had another profile to another subcluster to do the cloud computing. So we developed an API that changed all the network configuration, network tagging in the Brocade network, and also in the Mellanox network. It redefines the partition, so the traffic is not visible in in both networks, the high performance and the cloud, and some user auth and permissions. We deploy our the working nodes with Cobbler. It's a software that helps you in the having different repositories, profiles, and some kickstart steps to deploy the system. We use Chef for the low-level configuration. The Chef recipes connect the nodes with the NetApp storage and the monitoring tools that are the typical Ganglia, Nagios, and so on. And we share the case to the one admin user to connect between the master node and the working nodes with some repository of case. The first use case, study case, I wanted to talk was the same that Marco explained before. In our case, the great problem, the first problem was not the implementing this is the center that developed the KVM SR-IOV driver for single root I/O virtualization. Going fast, it simply takes your network card, virtualized, and you can pass one virtualized card called virtual functions to each virtual machine you want to deploy in your system. The problem was before that. To be capable of use the SR-IOV capabilities, you have to enable that option in the BIOS. You have to tell the the Linux kernel to have the IOMU. You have to define the virtual functions. You can use any number you want. But if you are doing this for getting high performance, it has no sense to make 20 virtual functions. Well, the main problem is that our hardware is provided by Fujitsu, and the network cards were OM. It means that they had their own firmware with their naming in the card. So we have to ask them for the sources to recompile with the option enable. It was a problem, many weeks waiting. They had to talk to Japan. Well, finally we also had to create all the Mellanox libraries, the OFED. So this is the result when you do LSPCI. In the host node, you have the physical HCA, the network card, and two virtual functions that you can pass to the virtual machines. In that moment, when we test the driver, it was not stable, and it takes us so hard. It was hard to get it working stable without failures. So we move on to another projects. We were working, and a few weeks ago, we see the great tattooing with that turtle, space turtle. So reading the release notes, we saw that it was funded by SurfSara, thanks to SurfSara, an option to support GPU consumables, giving the ability to give exclusive PCI pass-through access to virtual machines. Well, the PCI pass-through is the same tool that we were trying to use with the Infiniband networks. So, I did last Monday some previous tests, and it seems to work very well. Also, you select the PCI Infiniband network if you have 2 or 3 virtual functions. You can launch virtual machines. If you have consumed all the virtual functions, the virtual machines are pending. So it's promising. The second study case I wanted to talk was within two research centers. One were us, and the other was CESCA, the Galician Supercomputing Center. We set up, thanks to REDIRIS, the National Investigation Network, we set up a direct connection using the submarine cable we have that arrives in the data center that I was previously talking to you. It's a submarine cable, and we set up one lambda. It's 10 gigabits of dedicated connection. Well, also we arrived to the Spanish mainland, but we have to get to the other corner of the country. So we also have some steps in the way, and it gave us maybe some ping, well, not high, but constant, not very variable. And also, they require us to set up security in the communications. So the final tests between the two centers was about 600 bandwidth between hosts that were connected at 1 gigabit to the truncal network. So it was more or less good to that capacity. So the second step was, after getting that connectivity, we wanted to know if we could launch some kind of jobs, of scientific jobs, between the centers. The CESGA has a supercomputer, but they are full of jobs. They have more jobs than they can launch. So we have a bigger supercomputer. We have empty slots to execute. Maybe we can share some of the resources. We tested many various models, and one of them was the federation, was the trying to run their virtual machines in our computer nodes, and let's see if it was a good solution. We first look at the federation, but it's tightly coupled. We don't want to have all the users in our database and not in the other way. So it was too much close. We thought that cloud bursting was the solution, and they were at the moment also running OpenNebula. We read the docs, and we saw the remote provider could be a commercial cloud service or a partner infrastructure running a different OpenNebula instance. But that is not, that was suppressed from the docs in the last release, because it's not working. You can't cloud burst from your OpenNebula to other OpenNebula. Well, we realized, we tried to look how it was implemented with Amazon, but it relies on the Amazon API, so it's hard work. And well, that's because in the first day, the hacking session, that's the first question I made. Well, that's one of the tricky parts I wanted to find in the OpenNebula. If you have one host that is overloaded with many virtual machines, you can leave migrate. You have no cut in the service. You even can be working with a shell, and you don't realize. So it's very nice. The time of migration, if you have a high performance network, is really low. But if you had, as is our case, we have 4 storage nodes that are not working as a cluster. Yeah, there are separate volumes, so we had a quick deployment of a lot of virtual machines. So one of the nodes became overloaded. If you try to migrate, you cannot migrate the virtual machine image. You can redeploy, but we had the inconvenience that the client who was using the virtual machines had done manual work in every virtual machine that has been deployed. So if we undeploy and redeploy the virtual machine, she would have to redo all the work one by one. There was 400 virtual machines, so it was close to a deadline. Oh my God! Well, we finally do the bad way. We delete the virtual machine. We save the image with a snapshot. We created a new virtual machine and deployed and replaced the image. Well, that if you do the things like you should, you have a virtual machine template that you can launch and itself with the context or additional tools gets configured and nothing happens. Well, one of the good, not the bad, one of the good use cases is remote visualization. We have not any GPUs or hardware to accelerate visualization, and some of the jobs we do in computing, in high performance computing, gets a lot of data as a result. And maybe you want to see how is the data before you transfer all that gigabytes, terabytes through a network. So the solution was to we tried to do an SSH enabling compression to the login nodes, launch the graphical interface, and test with the software how was the data, and do some tests. It's quite slow. So we set up a virtual machine, and we enable it with a SPICE that is better. Performance is better than BNC. It has low bandwidth requirements, and also we install in the virtual machine the QXIL driver, so you can connect and not have a big window. So you have a desktop. If you have a big screen, you can set up to this resolution and work as if you were if it were in your own machine. That's a test with a ParaView, and I tested it outside the company in my home. I connected the VPN, opened the virtual machine that is prepared to run this software. It has the home directory mounted. So, and this is another software we use. It's amazing. It's for computational dynamics. This is a case from the tutorial. So you can run in the cluster, in the high performance computer, get the results in minutes, and run the visualization of the data and have the results in a low time. And finally, that was the client. that had the deadline. The deadline is when you have to send all the pictures to the cinemas. So it has no margin. The deployment was 404 virtual machines. They had their own infrastructure connected to ours through a IPsec channel, so they can transfer without using the public network. They spend 20 terabytes of hard drive and 12 terabytes of RAM and 12,000 cores. The consumption in electrical power was around 100 kilowatt, but we had 400 in the roof. So if it's day, they go without problems. If it's night, you have to pay that electricity, and it's an expense, but it's what it is. So thank you. You can reach us if you had any questions. You can reach us also in Twitter, in Facebook, or by email. We are open to new projects. As I say, we have some empty slots of computing and also in the cloud infrastructure. Thank you.